All right, in a prior video, we talked about the rational zero theorem and how to find the possible rational zeros. So we're going to be moving on to finding those zeros. So what I've highlighted here in the yellow is once you do the rational zero theorem, it is trial and error process using synthetic division. And what you're looking for is that remainder to be 0. If that remainder is 0, it is a 0 of the function, and then you can continue with finding the rest of the zeros. So here's what an example would look like. So here's our function. It's a cubic function. The degree is 3. So that tells me that I have up to 3 zeros. So we're going to list the possible rational zeros. So we're going to use our rational zero theorem. Here is our constant. Here is our leading coefficient. So we're looking for the factors of plus or minus 6 divided by the factors of plus or minus 1. So we're going to list them out. Factoring 6, plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Divided by factoring 1 is just 1 and negative 1. Now we divide them all by 1. So we have 2, 4, 6, 8 possible rational zeros. So now we have to trial and error and test. So we're going to test one of the zeros, and it's trial and error. My suggestion is to start small. So I'm going to start with x equaling 1, and I'm going to do my synthetic division. And now here we go. Bring down the 1, multiply it to 1, add the column, multiply the 1, add the column, multiply the 1, add the column. This remainder is not 0. So this is not a 0 of the function. So now we continue picking one of the other 7. So I'm going to test x equals 2. Doing my synthetic division again. Bring down the 1. Multiply it to 2. Add the column. Multiply the 2. Add the column. Multiply the 2. Add the column. This remainder is 0. So x equals 2 is a 0 of the function. So if you remember in a previous video, this leftover number set is going to be, drop the degree, x squared, x, and constant, a quadratic. So I'm going to write the function f of x equals the first factor. If the 0 is at x equals 2, then in factored form it's going to be x minus 2. The second factor comes from the result of synthetic division. X squared plus 4x plus 3. Now we can factor this quadratic. What are the factors of 3 that add to 4? Now we can set the factors equal to 0 and solve for x using the zero product property. Solve for x. And those are your 3 zeros of the function. they will then be your x-intercepts when you graph that function. So you could go and graph this cubic function. So these would be your x-intercepts. And we've done that on a prior video where we went and graphed these cubic functions. So you're welcome to pause and graph the function or graph it with your graphing calculator. Okay, let's move on to the next example. Solve this polynomial equation for x. So we're looking for the possible rational zeros first. Here's the factors of c. Here's the factors of a. So, listing out all the factors of 24. This gets pretty big. Plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, plus or minus 1. Now that leading coefficient is 1, so all we're doing is dividing all of those by 1. So there's your answer for all the possible choices. We have 2, 4, 6, 8, 10, 12, 14, 16 different possibilities. So we're going to go ahead and use synthetic division. Now, to make this process go a little faster, we're going to just go with the one that I know works. X equals 2, and we're going to factor it out. So we have a quartic polynomial, so x to the 4th, x to the 3rd, x squared, x constant. Put your coefficients in. 1, there isn't an x cubed term, x squared, x, and constant. Bring down the 1, multiply it to 2, add the column, multiply it to 2, add the column, multiply it to 2, add the column, multiply it to 2, add the column. There's that remainder we're looking for. So x equals 2 is a 0 of the function. In factored form, it's x minus 2. So I'm going to write the function. X minus 2 is factored out. Here's what's left. It's going to go in the second parentheses. We drop a degree. So now this is your x cubed term, your x squared, your x, and your constant. Now we have 3 more zeros to find. We try and factor it if we can. If it's a quadratic, then we could use the quadratic formula. So I'm just writing the problem again. I'm just going to change colors here. There are 3 more zeros in that piece of the polynomial. So what we need to do is try and factor it. Try and maybe factor it by grouping. And that doesn't work. So there's another method if you can't factor it. You're going to create another synthetic division problem working with that green. So we have x cubed, x squared, x, and constant. Coefficients are 1, 2, -2, and -12. Now you can go back up to your list and factor, again, one of those possible zeros. And that's trial and error. Well, I'm going to try x equals 2 again. So I'm going to bring down the 1, multiply it to 2, add it, multiply it to 2, add it, multiply it to 2, add it. There is another factor. So now what we have is the first factor, x minus 2, and now our new factor, x minus 2, and here's our leftovers, a quadratic, x squared plus 4x plus 6. Now in that quadratic, we have 2 zeros left. We either have to factor or use the quadratic formula. So in this problem, we have to use the quadratic formula because it's not factorable. So we need to find those last 2 zeros. So we'll say x equals -b plus or minus the square root of b squared minus 4ac all over 2a. We would simplify like we've done earlier in our class, and a problem occurs. We have a complex number. We have a radical, a square root that's negative. So these are complex. What does that mean is those complex numbers will not show up as x-intercepts. So we only have 2 x-intercepts. And here's what the function looks like graphically. Remember the original function was a quartic degree of 4, and then there was that x-intercept at 2, 0. It's a repeated 0 with a multiplicity of 2, which means it will not cross the x-axis. So in this case, it looks pretty much like a parabola because it only has really one x-intercept.